Hello everyone, my name is Ahmed Abir. Welcome to NANOG. So today we talk about the network operational simplicity via zero-touch provisioning. Are you guys aware of this topic? Have you guys used zero-touch provisioning before? Cool. So before I dive into the technical details, that's a quick overview of the agenda. We will go over the zero-touch technologies, what are different technologies involved, and its components. We'll go over the step-by-step flow, and we cover some of the deployment scenarios at the very end. And if we have time left, you can ask any questions if you want. So let's begin. So the problem we are trying to solve here, you guys as a network operator would like to automate the device automation. You want to basically integrate the devices with the controllers and orchestrators. And finally, you would like to make sure like network gives you all the indications, all the warnings if there is if the network behave differently. So I can easily categorize these three things into the three buckets. One is the day zero operation that includes the layer 1 connectivity, includes the software upgrade and downgrade, and provide the day zero configuration so that you can basically connect to your controllers, NMS systems, and NMS systems basically activate your services, and it will help you increase your business revenue. And then finally is the ongoing maintenance. You would like to troubleshoot, you would like to basically upgrade your packages, upgrade your softwares, that you can do it. So day 0 and day 1, traditionally it takes days and weeks or maybe months of time frame to just deploy the routers or switches from the lab to the production environment. And it's a very costly process for the network operators. We talked a little bit about the operations. This is not a topic for this today. So if I compare this thing, what we used to do and what we are doing today, you will understand like what we used to do requires truck roll. It was the very costly process for the network operators. It took long time to bring up the device. There was no integration between the NMS system and the controllers with the devices. There was another issue like each NMS system was the vendor specific. And it was based on templates, which only work for the specific vendors and never work for the other vendors. Finally, the way we used to basically pull the models, pull the information from the routers or switches or servers, it was basically not the machine friendly. So it was very difficult to automate. Now, using some of the technologies of zero touch, you can not only automate, you can deploy the devices faster, you can reduce your operational expenses, you can integrate with your controllers and orchestrator. It could be your open source, it could be vendor specific. You can deploy in the multi-vendor environment. Finally, if you heard about telemetry or PubSub or any other models, you can, instead of pull model, you can push the information out of the box based on your events, based on your models, based on your policies. It's up to you. So let's take a look at what are the components involved. If you see the left-hand side includes the technologies. These are IPXZs, ONI or ZTP. I put in two different buckets. The reason is IPXZ and ONI mostly used for system installation. What do I mean by system installation? System installation means when you basically clean up the box and boot up the box with the right image or the customer certified image, whatever. ZTP performs various operations. I'll talk about what is the role of the ZTP. From the component point of view, if you look at the servers on the right hand side, it requires DHCP or DNS for your reachability so that you can reach to the server. You can go to the right repository and get the images or get the configuration or scripts up to your requirement. It could be your orchestrator or your NMS system, which is basically handling DHCP, which is handling your storage, and it could be basically providing your final template. So let's take a look at each technology overview, high level, so that you understand each and every technology, what is the role of each and every technology, and then basically we'll go over step-by-step flow, how you guys can use those technologies. So iPXZ is the open source firmware. If you guys are aware of the server world or the data center come from, then you guys must heard about PXZ boot. So iPXZ is backward compatible with PXZ. You can run any PXZ commands with iPXZ, but it's providing additional information. It basically you can boot the boxes from your web servers like HTTP protocol, or you can run on your IPv4 network or IPv6 network. It runs both. So that is the, but it's only for the, it acts like a bootloader. So it's only for the system installation. I'm emphasizing on this thing. Some people mix up the iPXZ with the ZTP. So these are two different technologies, only used for system installation. So latest entry for the in the OCP platform, if you work with open compute platforms, the latest entry is ONI. ONI, it works just like the iPXZ. It basically provides the blade switches to provide the environment to basically for the automated provisioning. Just like iPXZ works with HTTP, it can also work with TFTP, but also it provides the DNS service discovery. It also provides the IPv4 and IPv6 link local neighbors. Again, ONI also used for only system installation, not for anything else. So if you just ship the box, clean up the box, and boot up the box, that is the whole purpose of the ONI and iPXZ. On the other hand, we have ZTP. ZTP performs various operations based on your requirement. ZTP can be used to download the configuration and apply the configuration. It can be used to deploy containers. For example, you have some third-party NMS system, and if you want to use some specific vendor agent to basically deploy the device through ZTP, in that case, you can use the Docker container, download it to the box, and you can run the PNP agent as a third-party container on the device itself. You can also upgrade the packages or download software through the ZTP. You can also execute the scripts. Script provide a lot of flexibility because with scripts you can do packages, you can download more scripts, you can download containers, you can do whatever you want. But it depends on your device as well. If your device does not support compute or the container or third-party framework, then you cannot perform some of the operations which I mentioned here. So I will talk about both processes, like how you can run the ZTP with the legacy devices and how you can run the ZTP with the latest devices which supports compute. So some vendors support compute, some vendors does not support compute. So this is a typical flow of operations for ZTP. I think you can pick any vendors. You will see more or less is always same. First device comes up, it starts the ZTP process. It checks if device is already configured. If device is already configured, it will stop the process. If device is not configured, then it will basically send the DHCP request to the DHCP server. DHCP will basically send the options. These options can be different for different vendors. It could be option 150, that means your TFTP location. It could be option 43, which means vendor specific S key. Vendor specific S key provides the location where to go and how to get your day 0 configuration. I'm showing here option 67 and 59, which means boot file name. So I'm also providing a location name, where to go and how to get your script or how to get your base configuration. So if there is no option, it will stop the ZTP right away. If there is an option, come back from the DHCP server, then it will download the script or the configuration file from the HTTP server or could be TFTP server. We never encourage TFTP server because TFTP server is slow, clear text, so there are so many issues. So we always recommend to use HTTP or HTTPS. So once you download the configuration or script, first it will check the size of the file. Just for a security point of view, we don't want to download a big file. So we make sure it is less than 100 MB. If you have bigger files, you can modify the threshold value, but we make sure like we have the files in MBs, not in GBs. So if file is beyond the size limit, then you can again delete the file and stop the process. If file is fine, then basically if it's a configuration, you can apply the configuration. If it's a script, it will execute the script. And script execution means it can download more packages, it can download, it can enable some CLIs into the box, it can do various operation. But this is what we used to do, and every vendor is doing it. So what is new here, right? The problem with this operation is this is still very vendor specific. Although we are using servers like DHCP, which is everybody is using. We are using like TFTP, HTTP, is all open source. But the problem is in some vendors, there is an agent which is specific to the vendor itself. And this is the problem. So how to make it multi-vendor? How to make it more friendly? So there is an effort going on in ITF to do ZTD with netconf or restconf. Netconf with Yang or basically restconf with Yang. Before I jump into the process, how you can achieve ZTP with netconf or restconf, you have to first understand what is the requirement. What are we trying to achieve here? So we would like to make sure any kind of deployment, whether it's the hub and spoke, ring topology, it's a clause architecture, or any kind of deployment, whether it's for SP, whether it's for DC, whether it's for web customers, we would like to make sure we don't want to pre-stage. I know multiple customers are still doing pre-staging. They basically put the configuration on the box and ship it to the facility, truck roll, and then basically enable the box. They call it ZTP, but it's not ZTP because it is specific for the specific environment. If you move it to a different environment, it won't work. Similarly, you have to understand like we need DHCP server, it's already there. You need to download the configuration, you need to download the images. Box comes up with nothing. So you have to make sure you have base configuration so that you can reach to the NOC. You can reach to your remote servers. Once you reach to your remote servers, then you can apply your templates, you can modify whatever you want. The main thing we are trying to avoid is truck roll. Truck roll is very costly for the operators. We checked with multiple customers. Some people told me it takes $1,000 to $2,500 just to basically bring up one device into production. So it is that much expensive. And if you have multiple truck rolls, then good luck. Similarly, for the in-band operations, what does in-band means? In-band means if you're using your data port, then it has more complexity because you have to make sure you can insert the node into the ring, you can remove the devices. You also need to make sure you have what kind of network. You have layer 2 network, do you have .1q encapsulation, or do you have something else? So it brings more complexity. You have to make sure you have all the things available before you start the ZTP process. And the last one is just good to have it. So everybody wants to have a robust connection with NMS. Everybody wants to have security, multi-vendor support, and configuration template. So there are two different kinds of deployment scenarios. One is the applicable to enterprise customers. One is enterprise, web customers, data centers, which is basically based on your out-of-band management. If you are basically talking about all the routers close to each other, then it's not a problem. You can basically have a separate network for your management. That is out-of-band. The other scenario is if you are coming back from a wild backhaul background, 4G network, 5G network you're talking about, these routers are miles apart. So you can see like the distance from one eNode B to other eNode Bs are maybe 4 miles, 5 miles with each other. In that case, you cannot have a separate network for the device to use for the management. In that case, we use data ports to manage the network. If you are using data ports, then we have to make sure if we have any kind of layer 2 network. If you have a layer 2 network in between, you need VLAN discovery. You need to discover the .1q encapsulation before you send the DHCP request. So this is typically applicable to the metro networks or the mobile backhaul. So once you understand these two things, now basically this is the right time I can show you how you can use ZTP with netconf to deploy into different environments. So first option is basically if you are deploying from the server point of view. Let's suppose you have a device which is a legacy device, do not support any kind of compute. If you do not support any kind of compute, still you can basically bring up the device using netcon. In that case, what will happen? Device comes up, send the request for the IP address or the options to the DHCP server. Once DHCP server assign the IP address to the device, it will also notify a script or the server, orchestrator or your controllers, like I assigned this IP address to a device, it will register a device into the controller. Device in a meantime, basically it will download the script and start negotiating the SSH keys with the controllers. Once the negotiation will be done, then orchestrator will apply the final template. If we go into details, there are multiple steps involved. So you can see first step is it will start the ZTP. It will send the bootstrap to the DHCP and get the options. DHCP at the same time sending request to the Python script, like I assigned this IP address, I lease the IP address for a device. Python script calling the RESTful API to the controller and register the device. At the same time, you are running the script or maybe downloading the base configuration and enabling the SSH server, netcom server into a device. So once your device have this netcom server up and running, it means it is ready to listen from the server itself. That server could be your controller, that server could be your script, that server could be your NMS system. It's up to your requirement. Once this is up and running, then your server basically apply the configuration. That will be a final template and your server will be up and running. This is called server initiated model. In this case, your device do not support any kind of compute. And you can see I am putting the script in the DHCP server. That script could be part of a DHCP server, some NMS supports already scripting part. That server can be part of the orchestrator as well. You can run anywhere. It's very flexible. You can put anywhere you want. Second option is basically you provision the device from the device itself. You enable, call the servers, everything from a device. How it will work? Similar way, device boot up, it will send the request to a DHCP server, get the IP address with options, download the script, and then device itself, because it has the capability to run the script or it has the capability to basically run anything into the compute, it will basically send the RESTful API to the server and register itself. So both, and then finally like your controller can apply the final configuration. Similarly, if you take a look at from that point of view, in that case, you don't need to run a separate script onto server. You can run basically a script inside your device itself, and or you can use the same script what you were using to basically enable the netcom server or the SSH into the network. Both method has pros and cons. This method basically is a little difficult to deploy if your server is far apart from your device, like the SP case. So in SP case, it is mostly the option 1 is more applicable. For other than that, enterprise, for the data centers, both the options are basically can be applicable. So still, but if you can see like whatever we are doing here, still we are taking help from the base configuration, or we are taking help from a DHCP server. Why not we just have a direct interaction with the DHCP server with netcon? Why not we just bootstrap with the netcon, right? So this is the active effort going on in the IETF. If you have seen a draft, there's a draft going on to do ZTD directly with the netcon or RESTcom servers. So you still can do basically ZTD with what I showed you earlier, but there are enhancements coming in. There are few things still need to be finalized, like DHCP option is not finalized. There are few other ways. There are multiple, like VLAN discovery is not defined in the draft right now. There are so many other parameters which are not defined yet. So it will soon, you will see like it's draft 18 right now or draft 19. You will soon see like more improvement. It's coming in, I think it's March time frame. So from the enhancement point of view, there's always a concern from the operator point of view is like DHCP is not secure. I can plug in any other DHCP, or I can plug in any rogue devices and I can hack the network. In that case, you can secure your network as well. You can secure via HTTPS as well, but this is a method which is already mentioned in the IETF as well, also standard based. What you need basically, each vendor needs to enable the CA infrastructure into the device. That will basically create the key pair between public and private, send the public key to the server that will generate the certificate for you, and send the certificate to the public server as well. When you ship to the box to the public customer facility, then the device compare the certificate issued by a device publicly and what is inside the device itself. Once you basically validate those things, you can basically authenticate a device. This is a legitimate device or this is a rogue device. So this is just a simple way of bringing the security into the network. So this is the draft going on. So I mentioned the draft link as well. So you can see like this is a heavy slide. What it's talking about, this is exactly the same process what we discussed earlier. Device boots up. It will basically try to discover the DHCP server first. DHCP server in return send number of boot server list. It could be one server, it could be server list, multiple servers, right? Then basically it will send the information to the boot server. The role of boot server is not only for the bootstrapping data, but it also for notification messages. The notification messages can be used for both purposes. Can be used for the visibility, like if you have any kind of warnings, errors into the network, or it can also use for the status completion. Let's suppose like device and servers able to negotiate the SSH keys or not. So those kind of operations can also be checked with bootstrap servers. Once you have this negotiation completed between the server and your device, then you can also download the image or download the script or download the configuration via netcom directly. These servers can be different servers on your compute or on your servers, or these servers can be part of single NMS system. And all the negotiation between the device and the bootstrap server based on the Yang model. This Yang model is also described inside the draft. So if you take a look at this Yang model, you will understand like it has all the parameters. On the left hand side shows the Yang model, right hand side I try to mention each and every parameter, what it means. It's up to you, it is very flexible model. You don't have to use all the parameters, you can use the parameters based on your requirement. So you can see first you have to define what is the version you need. It also basically asking, okay, what is the operating system you're using? You can also download the image. You can merge the configuration, you can replace the configuration, you can get the configuration, you can perform various operations, just like netconf. Nothing is special. If you are aware of the netconf, then it's just like netconf operations, nothing special. You can also provide some kind of security using the hash algorithm. You can see there is an image verification. With the hash algorithm, there is a space there for the security. Once you are done with the negotiation and downloading the base image or the certified image for the customers, then you can either apply the configuration or either apply the pre-configuration script, or you can apply the file template, or you can apply some operations. Once the operation will be successful, you will see 0. Greater than 0 means some kind of warning. Soft error means warnings. Hard error means you cannot perform the operation. There is some serious issues, or maybe some connectivity issue, right? So this is basically we are talking about the bootstrap point of view. So you can, it is still in the draft, it is coming in. So we are planning to enhance our platforms based on this thing so that we can avoid the script completely. We can avoid all the number network. So when you talk about number network, now we have different use cases. We have different deployment scenarios, right? It could be, so let's take a look at it one by one. If you have the out of band management, then your life is much easier. In that case, basically you have a separate management port which is basically managing your network. In that case, you don't have to worry about so many complexity. You just plug in the box, it will discover the DHCP, get the IP address, and you're good to go. But if you are using the in-band for some reason. I know some of the customers using in-band. Then there are multiple scenarios. It could be your layer 2 network. Layer 2 means maybe simple flat VLAN network based on the encapsulation. It could be based on the G8032, maybe wrap rings. It could be anything. So in that case, first scenario telling you like device must be capable of discovering the VLAN before send the request out to the DHCP server or to the any other servers. So you need to know the encapsulation on your port itself. So you have to somehow snoop the information. You can use standard protocols like MVRP, or you can snoop the IGP protocols, or you can snoop the VRP protocols and discover the VLAN. Second scenario is the most common one. Everybody needs it because we are all moving towards the MPLS or layer 3 network. Even we are basically bringing the layer 3 data center as well. It could be based on VXLAN, it could be based on segment routing, it could be based on anything else. We don't care. Because those things comes in when basically you apply the final template. For the day 0 point of view, you just need to bring up the boxes. So that scenario 2 basically we'll talk about in detail. We have multiple scenarios with the layer 3. The third scenario is basically a corner case. It is not applicable to everybody. In that scenario, what we are saying basically you can have DHCP server on different encapsulation and your HTTP or your controller on the different encapsulation. In that case, it is a little bit more complex. So let's suppose if you're familiar with the option 43. Option 43 is the vendor specific what we used to use for the zero touch provisioning. If you're still using it, in that case, if it's a layer 3 network, so first hop needs to configure as a DHCP relay. That's a basic DHCP requirement. This is nothing special for a ZTD point of view, but you need to configure DHCP relay so that you can send the information out. In that case, device directly send the information to the DHCP server or NMS system and download the configuration directly from the controllers. If you have a multi-vendor environment where you do not support option 43, in that case, you need some base configuration or some script to download the base configuration of the script so that you can have reachability to the remote site. So let me go back. So when the device comes in, it will send the request, it will get the TFTP information or maybe the HTTP location information or maybe some other location to download the configuration of the script. Once it has a script, it will know like where is my server is, and then it can go to the somehow it will basically reach out to your orchestrator or your controllers. The third scenario is basically, let's suppose you do not have numbered network, you have IP and numbered network. Because we are basically saying for best practices in the layer 3 network, use IP and numbered because it will reduce your IP addresses significantly. You don't have to configure IP addresses on your links. You can just have to configure your loopbacks and you're good to go, right? And IP and numbered basically make your life easy as well. How? Let's suppose you want to insert the device into the ring. When you insert a device into the ring, into the IP numbered network, you basically break the subnet. When you break the subnet, you have to go to the adjacent site and you have to reconfigure your IP addresses, right? If it is an IP and numbered, you can add the device, remove the device, and it will not impact your operation. This is seamless. So in summary, you can basically upgrade your multiple devices in parallel. You can reduce your operational costs. It will reduce your chances of configuration failures or the reachability informations. There are multiple references I put together here, which can be helpful. You can take a look at demo as well if you want. We have posted there. That's all from my side. If you have any questions, feel free to ask me. Okay, thank you so much.
All right.